8th graders, pretty quick and easy little assignment for you guys today. This is really our first Amplify assignment for this unit. Last week we went over averages and just kind of did some introductions to thermal energy. So today's assignment is 1.3 thermal energy, and their learning targets are, I can describe the motion of molecules in samples of different temperatures. So we really studied energy a lot, and this is kind of our little introduction into figuring out how energy plays into A, motion of molecules, and B, temperature. Okay, so for your first part, I want you guys to open your OneNote, and we're going to add some notes in there. So as we are starting a new unit, you will need to add a new section, thermal energy. So if I go into my notebook, I've already added this thermal energy section right here. So at the bottom, you'll just click Add Section. And then in that, you guys will need 2 new pages. So again, as this loads, you'll see at the bottom, Add Page. You guys need to click it once because there's already a new page added for you. And then rename the first one Vocab, the second one Key Concepts. Okay, and then you guys can go ahead and add molecule, a group of atoms joined together in a particular way. We're going to study in about 2 units, start really studying molecules and atoms and the periodic table, and then start looking at chemical reactions. Okay, finally, key concepts. You guys are going to add 1, 2, and 3. Things are made of molecules. I like to say matter is made up of molecules. That's a little bit more scientific word than things. So matter is made up of molecules or other types of atom groups. And when a thing gets hotter, its molecules are moving faster. When a thing gets colder, its molecules are moving slower. Again, I really prefer the word matter. Okay, so when matter gets hotter, its molecules are moving faster. And when matter gets colder, its molecules are moving slower. Okay, so that's going to be your guys' concept of being able to describe that motion of molecules for samples of different temperature. All right, back to our lesson. Moving on to part 2 is a little sim exploration. So I want you guys to take about 3 to 5 minutes to explore the sim. Your link is right here. If you right-click it and hit open link, it should pop up for you guys. You might have to log in based on where you're at. But you basically can see you have some things that looks like it's pretty simple, but once you guys get into it, you'll see different things that you can do, different types of samples. You guys can check out what's going on up here. You guys can see what's happening here. Really quite a lot you guys can do. You can look at energy transfer, kinetic energy, and you guys can see this little key that kind of describes kinetic energy. You can pause, you can change the speed. So go ahead, mess with that, see what these little plus signs do, pay attention to what happens here, check out what kind of information you guys can get on run and analyze. So again, the things you should look for, what are some things you can do in run, and what are some things you can do in analyze. Okay, so take about 3 to 5 minutes to explore that, and then we're going to move on and have some little directions of what you need to do specifically in the sim. So if you already have the simulation open, great. If not, here's your link again. You're going to add 2 of the same size samples. You guys kind of saw when I was going through a little bit and in your exploration that you could add either small, medium, or large. You guys can pick small, medium, or large. Just make sure that your 2 samples are both the same. So if you pick small for the first one, pick small for the second one. Make 1 sample hot and 1 sample cold. Again, in your exploration, you guys should have figured out how to do that. If not, go figure it out now. And then observe the differences in the 2 samples, okay? So what we're doing is simulating basically what we did in our demonstrations last week. Last week we kind of saw a little food color race where I had ice cold water, warm water, and then I had hot water. And I added food coloring. In this one you guys have 10 degrees Celsius water. So remember, water freezes at 0 degrees Celsius. And then 70 degrees Celsius water. Remember that water boils at 100 degrees Celsius. So these aren't quite hot or cold, but they are definitely a big difference in their temperature. So 2 samples of water, 1 hot and 1 cold. Food coloring is added to both samples. The food coloring spreads more quickly throughout the hot water and the cold water, and this should not be new information for you guys, especially if you did the thermal energy demonstrations last week. Okay, so what we're getting out of this though is why. Okay, so this is the why. We learned last week that yes, the hot is going to spread a lot faster than the cold, but why? Why is that? So think about what you guys are learning in the sim, and then you're going to do this in the sim just to see, like, all right, if we were to make an explanation as to why this happens, let's use a sim where we can see things happening on a molecular scale. And then answer these 2 questions. What do you notice about the movement of the molecules in the 2 samples? So compare your hot to your cold. How are those 2 samples moving their molecules differently? And then explain what you discovered from the simulation about why food coloring spreads faster in warmer water. So really relate these two questions. Pay attention to the movement in the hot and cold, and how is that going to affect the fact that the warm water distributes those dye molecules faster. Okay, moving on, you have a little reflection question. So reflecting on the simulation, look at the key. Here's your key right here, where we have molecule speed. Low is kind of this black color, high is yellow. In the 4 images below, so we have image A, image B, image C, or image D. Answer the reflection question and explain your response. So basically you have one of these images is correctly represented based on molecule speed. Okay, so answer, which image shows the difference between the speed of molecules in hot and cold water? So which is the correct image? Go up to draw, use your guys' draw tool to choose A, B, C, or D. You guys might need to use a better color than that. There we go. So circle A, B, C, or D on those, and then explain your choice here. So type and click and write your choice in there. And then the last little part that you guys are looking at today is this little reading. So if you guys have ever heard of absolute zero, it's an awesome concept. It's something that we haven't seen before, and it's really hard to make absolute zero in a lab. But you guys will see what happens to molecules when an object reaches absolute zero, and you'll learn a little bit about what absolute zero is. So it's a pretty cool little read. Basically, with the weather the last couple weeks, we haven't even come close to absolute zero. Okay? So which of the following would be true if something was at absolute zero? And if the molecules of a sample speed up, what else happens? So use your guys' draw tool to circle the correct answer for those two questions. And then finally move on to your wrap up. Do you have any questions? Circle yes or no. If you have anything that you want to know about, go ahead and type them in there. If it's something that's preventing you from completing this assignment, make sure you guys get it to me right away. And then finally circle 4, 3, 2, 1. How do you think you did? Okay, I hope you all are having a wonderful day, and I will talk to you soon. Bye.